Hi everyone, welcome back to my mathematics teaching channel online today. In the first introduction to calculus course online that I have been developing so far, follow the sequence of the chapter 1 to chapter 7 and the sequence of on the lesson. I have shown you what is calculus? What's the meaning of derivative? What's the meaning of limits? What are they? And from the lesson yesterday, I have shown you to use algebraic skill to find the derivative of the function. And today, I would like to show you how to get the derivative function based on the given function. So let's get right into the lesson today. So on the board here, I have two graphs, and I call the function f of x. So if you look at the first graph here, we have a function f of x go up and down like this. Now, how are we going to get the derivative of that function? So, if you want to get the derivative of the function, you pay attention to the slope of the function because the derivative just means the slope of the function. So we pay attention to that. And how do we know? First of all, we recognize this is the linear function. This is just the shape of all the linear function put together. And the slope of linear function based on the direction of the line. So if the line going down, the linear have a negative slope. If the line going up like this, the linear have a positive slope. So if you look at into the first segment of this linear, this is the negative slope. So based on that, we know that our derivative function will have a negative slope. Now also, we pay attention to, by the shape of it, so this is the constant, linear is a constant slope, right? Have a constant slope, and it only have one slope. So let's check the slope of this linear line. So from here to here is the rise, and if we draw the vertical here is 1 unit. From here to here is 1 unit. So this linear have a slope of 1, and the function decreasing. So because the function decreasing is going down, we have a negative slope. So now if we get the slope, we will start from the negative section because the function decreasing. So now, and it have a slope at -1, so this is -1, and we're going to, we know that at this point, it's a sharp point, and therefore the derivative is not as it. So we will have an empty circle, and because the slope is constant, so we have the derivative, the slope is constant. And the slope is constant represented by the straight line, the horizontal line, because it's a constant slope. And also it's negative, so it falls in the negative quadrant for the y value. And at this point, we notice this is a pointed sharp point and there's no value of derivative as well. The derivative does not exist. So we mark it at this empty circle. It means this derivative is not exist. So now let's look at the next segment of this linear. This linear have the same slope like this one, which is slope is rise over run and 1 over 1. So the slope equal 1, slope equal 1. But however, the direction shows us that this linear is going up, so it's increasing. So if the function is increasing, it go up like this. we will have a positive slope. So it increasing, the function increasing. I put the arrow here for increasing, right? And the arrow here go down, indicate function decreasing. So at this point, function increasing, and still the slope is 1. So from here to here, and at this point, it no derivative. So we represent by the empty circle, and the slope at 1. So this is how we sketch this derivative. Continue with this. We know negative, so keep going. At this point, there no derivative, so we have a constant line like that. And this is function increasing again, and the slope still 1, so we will have this. And that is how we sketch the f' x for this linear. The same thing, this happened, this is negative slope, so we have negative minus 1 from here, from this point, right? So negative minus 1, so we have this line. So now from here to here, we have a slope at 1 as well, and at this point, there's no declivity, so it goes like this. So this is how we sketch. So each of the segment like this is the f' of x. You see f' of x, f' of x for each segment. So let's check again. Function decreasing, negative slope, and a constant slope. So the slope here is at -1. Function increasing, constant slope, and slope here at 1. And negative, so negative slope, and positive slope for this, and negative slope for this, and positive slope for this. So we're done. That's how we sketch the slope, the derivative of the linear segments function. Now, let's take a look at the second draft. So in our second draft, we have a curve, right? So let's pay attention to the way the curve going. So this is function increasing. And at this point, it form a negative function from negative, but go up, become positive. And at this point, the function have a tangent line, the horizontal tangent line at zero, right? So this is the curve, and the function increasing, and then finally, the slope of it becomes 0 at the origin. So now we're going to sketch this one. Because this function increasing, so we have a positive slope. So let's start from here. We have a positive slope. However, it goes to 0 because at this time, our slope equals 0. M equals 0. So right here is 0. So we have a f of x, which is positive. And at 0, it goes to it have a tangent line here 0, so it goes to 0. Because we're talking about the slope, right? This is represent the sketching of the slope of the function. So the slope of this function, because function increasing, so the slope is positive. And here is the y value is positive, right? Down here, the y value is negative. So now, at this point, the function starts decreasing, right? Follow the shape, the slope of this function decreasing. Therefore, we have a negative slope down here. And we have a negative slope until at this point, the function start increasing again, right? Start a little bit slightly increasing, right? And then the slope becomes 0, right? We have a horizontal tangent at this point. So at this point, we know that our derivative function will be negative, but then start go, because at this point the function is start like increasing. So it start increasing, and slope becomes 0 at this point. So it go to this point because the horizontal tangent line here. So it go to 0. Now at this point, we have a horizontal m equals 0 again, horizontal 0. So we know that our derivative function will have a positive slope, right? We have a positive slope because this, from this segment, the function is increasing, increasing. So therefore, we have a positive slope. So we have a positive slope. However, we will have our slope becomes 0 at this point, so we'll touch the 0 point. Now, at this point, we wonder if our pen pick up like this or pick down like this. And obviously, you see at 0 here, right? Our slope equals 0. So our derivative touched that point, but look at the shape of the function. The function going down again, decreasing again. So the function now will have a negative slope. So therefore, it cut through this and it becomes like this. So this is the shape of our derivative sketch. So I'm going to sketch it again to make it look a little bit nicer. So this is our red. The red color, I don't know if you see it from the computer, is the derivative function. And the black one is the function. So this is the shape of our derivative sketching. So I'm going to mark here. This is f prime of x, the red one. So this is the f prime of x. This is f of x, the black original function. This is f prime of x. So in this video lesson, I show you how to sketch the derivative function given the f(x) function. Now we will probably do the opposite in the next video. So this is how we sketch, follow the slope and follow the horizontal tangent line. Now this topic is actually a little bit tricky and need time to practice. When I first learned this, I barely do know how to sketch it probably. But by practicing like over the times, I got it. So this topic's a little bit difficult actually. So now, because there's a lot of information watching the slope up and down, and you know, like the function have a shape like this, and what is the derivative shape should look like. Anyway, I am going to go to the next part, which is the next board. I have another 3 function on the next board. So let's take a look at the shape of this cubic function. So this is we call a cubic function. So this is a cubic f of x function, the black one here. The cubic function is the degree of, have a third degree. Now, let's pay attention to the shape of this function. This function is decreasing, right? Obviously, you can see that this is f of x is decreasing. So I put the arrow down for decreasing, right? So the arrow down indicates function decreasing. So if function decreasing, what is the slope of our derivative? Negative or positive? Of course, it's negative, right? If function decreasing, we have a negative slope. So our sketching will be in this quadrant because all the way down here, the y value is negative. So let's start from, we have a negative slope. So this function is decreasing, we have a negative slope. However, the function is decreasing, but its slope is actually increasing. Slope means this is the function decreasing, but its slope, let's say you have at this point, you have slope like that. At this point, the slope like this. At this point, the slope go like this. So at this point, slope go like this. So you can see that the shape of it is seem like the slope. This is we're talking about the slope of the tangent line. So if by looking at the slope of tangent line, this is a positive slope because the slope is increasing. The function is decreasing, but its slope is increasing. So therefore, the function decreasing, so we have a negative slope, and then the slope at this point, the slope is decreasing, but then it slightly increase up to the 0, right? So the slope at start is decreasing, right? M decreasing, but then slightly increasing, and at this point, we have a slope of 0. So our sketch will be based on this point in slope. So at this point here, we have the slope of 0. So our derivative will look like this. So we have a negative slope, so that's why it's in this quadrant, right? It's negative. But then the slope is start increasing up to 0, right? Decreasing, and slightly increasing up to 0. Now at this point, we have an inflection point. Inflection point, it means that the chain inflection point, the chain between the concave down and the concave up. Now in the future, we're talking about what is a concave down. So concave down is like this. That is a concave down. And concave up is like this. That's concave up. So the concave up indicates the slope positive, concave down indicates slope in negative. So this is the concave down, right? So the slope here is negative, and that's why we have it in the negative quadrant. But then it's slightly increasing to the 0, so it's up to 0. Now the turn here indicates we have a maximum point because we have an inflection point, and we have the slope is changing from negative. The slope here is changing from concave down. Actually, this is concave down and concave down. So the slope is keep decreasing. So we still have a negative slope. So you see that this function decreasing, right? So it have negative slope, and that's why our derivative in the negative quadrant. And then at this point, the function have a horizontal tangent line, and the slope here equals 0. So therefore, our derivative touch the point 0. Now this function still concave down, right? So still decreasing, and keep decreasing on the way down. So at this point, our function will keep decreasing and like that. So this is how we sketch the f prime of x. So I'm going to mark here, this is f prime of x. So this topic is a little bit tricky, right? We have to watch the shape of the function and understand this is a negative slope because the function decreasing, and you see the slope here decreasing. But however, it seemed to be like changing a little bit in the positive way, right? And that's why our derivative go up. And then at this point, our slope is at 0, so our derivative at 0, and then the function keep going down, concave down, right? Concave down show that the function keep decreasing on the way down. So therefore, we still have a negative slope on the way down. Anyway, after the sketching, I will show you the hint to recognize and where do we start to sketch it, right? So I will do a summarize for you, so it will be a little bit easier. So now let's go to the next graph. So our next graph here, if you look at, we have two graphs, right? F of x and f of x. So let's take a look at the second graph here. So here we have a linear, but we have an empty hole here. Indicate that at this value, the y value does not exist at this point. The y value does not exist. And if we look at, this is the linear function. So the linear function has slope. Let's calculate its slope. Rise over run. So the rise here is 1 unit. The run here is, the rise here 2 units, sorry. I put the scale here too, right? So the rise is 2 units and the run is 1 unit. So this have a slope of 2. And the slope of it is increasing. And it's a constant slope, right? This linear only have 1 slope. Constant slope at 2. So our derivative will be a constant slope at 2. However, at this point, the derivative not exist. We have to mark the empty circle here, right? And then, because it's a constant, so we have a constant line, the slope constant like this. Because this slope never change, this slope have a slope of 2 and it never change. So it's like represented by a straight line, and never change. The horizontal straight line and never change. So this is how we sketch our derivative slope, the derivative function. So this is f of x and this is f prime of x. Now, let's go down to here. Let's make an observation for this function. This f of x function have a curve a little bit, but it looks like a horizontal slope. So it looks like the slope of this is m equals 0, right? It looks like a horizontal. Now, it going down, shifting down like a function decreasing, but at this point, it's straight. We have a vertical straight line, vertical straight. Now, if the function is vertical, and we learned before, if the vertical line, the linear, right? If we have a vertical line, what is the slope? Slope is undefined. So at vertical line here, the slope is undefined. And then the function is slightly go up a little bit, but still flatten out like a horizontal. So here we have slope of m equals 0, right? So now let's follow that and sketch. Our derivative will be, the slope of our derivative will be almost 0, right? Like almost touching a 0 here. Touching a 0 here. Now, up to this point, our derivative is going down, right? Because the function going down, negative. Now, negative. And then, at the tangent, vertical tangent, we have a vertical tangent here. So this derivative will never touch the tangent, right? It's getting close and getting close, but it never touched the tangent line, right? So this is how the situation look like. And now, if you look at from this point here, again, this derivative is never touched the tangent line, right? And then it slightly curved to the zero. So it slightly curved to zero. It go like this. So that is the f prime of x. Because we have a function have a vertical line, so this derivative not as it have a hole, right? It have a break like this, right? A centione discontinuity, right? So that is the f prime of x of our derivative look like. If we have a function with the shape look like that. Okay, so at this point, I want to give you a summary of how we're going to sketch this stuff. And again, it's a little bit tricky, so let's figure out what is the hint here. So in summary, I'm going to give you the hint. So after we sketch the graph of derivative graph, let me give you a summarization of what we should do when we try to sketch the derivative graph. So for the summarization part, I wrote it here. We should pay attention to first the slope of the function, right? And we pay attention to where is the maximum or minimum of the function have a horizontal tangent line as slope equals 0. For example, here, right? When the function have a maximum value, the slope is 0. And here, and here. So we mark the point where our derivative go through, m equals 0. So from the horizontal tangent line, we go down here, we mark 1 point here. From here, we go up here, we mark 1 point here. And here, we know the horizontal tangent line right here. And our curve have to go through this. So we know the derivative have to go through this point. Now we will say whether or not our derivative slope should have positive slope or negative, whether we put our pen on the positive quadrant or on negative quadrant. And then we look at it, we say, okay, this is a function increasing. So we know our pen have to be on the positive quadrant, right? In here, positive, not down here. And therefore, we know that we have to draw the curve, go through this point, which is go down like this and go through this point. Also, we pay attention to where we mark our point and we watch the function, right? So we know the function decreasing, so our slope have to be negative. And at this point, we have the root of the function, which is we have a horizontal tangent for our derivative here, right? And at this point, we have a positive this horizontal tangent for the function. It means our derivative have to cut through this point. Now we watch the function increasing, so we know it's positive slope. And then we know at this point, our derivative go through and the function decreasing, so we have negative slope again. Now, these are the important things we pay attention when we sketch the derivative graph. So first we check the slope, mark the line where our mark the 0 point where derivative going through, and then watching the function increasing or decreasing, right? If the function increasing, then we have f prime of x will be positive, And if it's decreasing, then f graph x will be negative. And now we know that after this, my third hint to you is pay attention to degree of the function. So how many degree for our original function, the black curve here? Let's count. We have one root here, and two root here, because this is remember this is two real root in quadratic function, this is degree 2. So we count at 1, degree 1, degree 1. So 1, 2, and 2 of this, so it's 4. So our function, the black one here, have 4 degrees. So this is x to the power 4, degree 4, right? But our derivative function, what degree of the shape is? 1 root, right? 1 root, 2 root, 3 root. So this is x to the power 3, degree 3. So you see that the function, the f graph of x, has a degree, less than f of x by 1 degree. So if our function is 4 root, right, then the derivative of it have a 3 root, have a 3 degree, the third degree. If our function is x to the power 1, which is 1, x to the power 1, degree 1, then our constant have 0 degree here, derivative, right? Have 0 degree here. Now let's check this one. If our original function is a cubic root, which is degree 3, our derivative have a shape of parabola degree 2. So it's down by 1 level, right? Our linear have degree 1, our derivative have 0 degree, right? None degrees, no degree in here. A constant is y equal 2. It's a constant, there's no degree in there, right? So you can see that the hint here, I give you 3 hints. First, watching for the slope, marking where the maximum level of the original function, where the maximum or minimum level, where our slope at 0 mark this point, right? So we know the shape, our shape will go through this point, and pay attention to if the degree of the function is higher than our derivative by 1 level. So that is on for the sketching video today. And I hope that you enjoy the video in the sequence that I developed from my first introduction to the calculus course. I like to put things in the sequence so that you can see how the math reconnecting each other. So I have shown you where the limit why the derivative derived from the limits, and what is the calculus, what is limits concept. And then we use the derivative to find out the derivative of the function. We use the derivative rule yesterday. And today I show you how to sketch this graph function. Now in the next video, I will show you how to go backward. So given the derivative function, how do we sketch the original function? So that is the next video. So stay tuned for this. And thank you for watching. And don't forget to give me a thumb and subscribe to my channel. Also, in the future, you can register to the home course online I am developing right now, give you on the concept of important concept of the first introduction to calculus course, because this is very important for on high school student and first year university student. This concept is very I mean, like a lot of concept intensive, right? So it helped you. I'm sure that my teaching and my video, my course online, developed online, will help a lot of students, a lot of you. And if you like my teaching video, whether or not you're curious or you like it or you learned, even though you're not in math major, and you just want to understand about what is calculus and what is mathematics, right? Then you should try, and we share our knowledge together. And thank you for your support. Thank you for watching. Bye for now. See you in the next video. Stay tuned for the next sequence of this video, which is we go backward. We go from given the function, derivative function, GRAPHS, try to get the original function. And of course, it will be harder, a little bit, right? Anyway, bye for now.